This problem is so basic that you can't make it worse. I mean, even you try to solve in the worst case scenario, you end up getting time complexity as big of n. And similarly, if you solve in best case also, it will give you big of n time complexity because this problem is so simple. But here we are trying to understand array traversal problem or the array traversal pattern which is asked in most of the interviews questions. So the problem is simple. You have to just add 1 at the end and you have to return the final array. But if you try to solve it in brute force, what we can do is, as given in the example, we can just convert the array to integer and then do +1, and we can just convert back to the array and give the result. So that will take some other space complexity. So this is the only possible worst case scenario that one can come up with. Now see this example. Here we are just trying to attempt this question in worst case manner or brute force approach. So we are just converting the array to number, adding 1 to the number and converting back to array. Let's see in the code how it works. So if you try to see, and I am taking this number so that it is the most difficult input from this problem. So first we can have a string builder, then we can append every digit to that string builder, and then we can have a bit integer like big integer because number might be used, and then we save that number to this big integer because here, as we discussed, we are trying to convert that array into a number. Now we have this number, so we can have a result variable also, and we can have a output array also in which we will store that final result. So here also we have to iterate over the result because as result contain the number, so we kind of taking output array and storing everything to the output, and finally we return to output. So let's try to run this and see how it works. So if you see, this is the result that we expect. Now let's think of an optimal approach. So what we can optimize is the space complexity. And in this example, we are just trying to iterate the array at once and try to resolve it on the go. So we are again taking the same example and we are iterating to the array, given array. We are not taking an extra space this time. And for every iteration, we'll check if the current number is less than 9 or not. If it is less than 9, then we can just do digit plus plus or the current element plus plus and return the digit. So this will be our final answer. But what if it is greater than 9? Then for that, for a particular time, a number cannot be greater than 9, but it can be 9. So if we do +1, it will become 10. So for that number, as we do simple sum, we assign that number to 0. That's what we are doing here. We are just assigning this digit or this place to 0. So most of the problem will be solved in the above for loop. But if in case all numbers are 9, that is what our case is. So we can have a result variable which is an integer, and the length of this integer array is +1 to the length of digit or the given integer array. We just assign the first element of that array to 1 and that will be our result. Try to imagine this. You are not doing anything fancy. You are just declaring an array whose size is greater than the digits or the given array size, and you are just assigning the first digit to 1. This will solve all of the problem which is not solved by our for loop. So obviously you are getting out of that for loop with only one condition, that all the numbers are 9, and when you return the result, let's see. So yeah, this is the final output, and let's paste this to LeetCode. So I've pasted the same thing in LeetCode. Let's try to run. All cases are fine. Everything is working. Let's submit this. So yeah, you have beaten 100% of the programmers out there. So try to rethink. This is a problem that looks simple, but interviewer may trick you to optimize the brute force approach, because the brute force approach itself giving you best time complexity. So you have to tell that this cannot be have time complexity greater than that, but we can optimize the space complexity. So see you in the next video.